All right, welcome to our very last class of Math 160. We started with some quick clarifying questions based on the final, any little loose ends like that. As a reminder, my review session is this Saturday from 1 to 3 p.m. Please join me. You will not be alone. There will be students from other classes, 098, 096, 104, whatever it is, but you will not be alone. So please come join and let's do some math together as a community. All right, so the first thing I want to look at is a question that Stephanie and I were looking at yesterday. So notice I have my Unit 9 notes opened. I actually want to open up my Unit 2 notes, or excuse me, my Unit 8 notes as well, just to have that. Actually, I think I opened it already. I did. Okay, perfect. So we're going to go into the homework assignment. And I want us to look at Unit 8. So Unit 8, estimates and confidence intervals homework. So yesterday, let me reset this. Yesterday, we were looking at question number 3. So first off, these are not too bad. For a confidence level of 88%, find the critical value. For a confidence level of 90%, find the critical value. The nice thing with the 90% is we actually have those common critical values for Z. So if you look at your table, and I drew one out here, it's in your notes as well. If you look at that table, you'll see common critical values, 90%. The Z score would be 1.645. So that's essentially what we would put here for question 2, 1.645. For question number 1, remember that's the middle 88%. So that means you have the remnants in the tail. So you want to figure out what Z score pertains to that particular area. So I want you to think about that, play around when you get a chance. But 3 was a very interesting problem. So it says you measure 28 turtles' weights and find that they have a mean weight of 77 ounces. Assume the population standard deviation. Notice that it said the population standard deviation is 7.7 ounces. So based on this, construct a 90% confidence interval for the true population mean turtle weight. This one's actually really interesting because usually we'll use the t distribution when the population standard deviation is not known. In this case, we won't. So I want you to think back too, and it may help if I show you. Let me open up the Unit 8 notes. I want to show you a specific formula. So let me scoot down, and we're talking about population means and sample means. So we're going to bypass all this proportion stuff, right? So we're in 8.2, estimating a population mean. And we tend to use our t value for our critical value. So notice here, we're going to use E to calculate the margin of error. And that formula is your t critical value multiplied by the sample standard deviation divided by the square root of n. Well, this time we actually do know the population standard deviation. Typically, you'll use t when you don't know the population standard deviation. But when we do, we use a Z score as our critical value. It's a little bit different. So what I'm going to write down on my sheet of paper is that my error is found by calculating the critical value, the Z critical value. So Z multiplied by the standard deviation for our population, which is sigma, instead of S, divided by the square root of n. So we're using the same structure, but we're replacing t with z, and we're replacing s with sigma, okay, because we actually have that information. So I'm going to write down here that we know that we have 28 turtles. We know that that sample of turtles has a mean weight of 77 ounces. Sample, mean, x bar. So x bar is 77 ounces. We're told that the population standard deviation, sigma, is 7.7 ounces. We want to construct a 90% confidence interval. Perfect. So for the true population mean turtle weight. So essentially what we're looking at here, and again, if we look back at our Unit 8 notes, we're looking at creating this interval where we take x bar minus the mean, and then x bar, well, I can't talk, X bar minus the error is less than the population mean, which is less than X bar plus the error. So in Lumen, it wants us to write down essentially the sample mean, boom, there it is, and then plus or minus whatever the error is. That's our responsibility. We have to figure out what's the error. So let me stop my screen share just so that I can go over to my notes. And I wrote down for you the formula that we're going to be using in this case. So we see that our sample mean is 77. We want to essentially satisfy this particular notation, sample mean plus or minus the error. We want to construct a 90% confidence interval. According to our table of common critical values, our 90% is a z value of 1.645. So I'm going to write E is equal to, we're going to replace z with its value, 1.645, and we're going to multiply that by the population standard deviation divided by the square root of n, and n is 28. So we're going to go ahead and take our calculators. 1.64, oops, let me clear this out, 1.645. You should all make sure that you're trying this to verify that your work matches mine. And then when we calculate and we round to 2 places after the decimal, which is what the Lumen software is asking for, we find that my error is 2.39. So we'll notice that when we write our interval into Lumen, and actually I can share my screen, but I'll write it here first. It wants us to write it as the sample mean plus or minus the error. So that's what we're looking for in Lumen. So let me go ahead and share my screen with you really quickly, and I'll input it so that you can see what's going on. And hopefully you'll be okay with this. So the sample mean plus or minus the error, 2.39, and then we go ahead and we submit it. Okay, and then we're done. This one was definitely a tricky one because typically when we look at estimating a population mean, we're looking at the t distribution, not that one. We're looking at the t distribution. So I think that's what was freaking a lot of people out. We're thinking, what do we do? I know the population standard deviation. Well, this is what you would do. Nick.
I keep having, yeah, I was gonna ask if you could do question 4 because I keep having an issue with that. Because I keep trying to solve it. Like I'll show you my equation that I'll show you what I have right now. It says assume that the sample is used to estimate the population mean. The margin of error corresponds to the size 16 with the mean of 63.5 and a standard deviation of 21.6 at confidence level of 90.
Okay.
And it keeps saying that the answer is 9.5, but I got 8.883.
Okay. Let's.
So I'm close, but like I don't know why I keep doing wrong.
Okay, let's figure out this one just because everyone can see this problem, and let's see if by answering this question we can identify what's going on with yours. Okay, does that sound good?
Yeah, that sounds good.
And I love it because Donna also wanted to do question 4, so that's perfection. Okay. Looking at mine, assume that a sample is used to estimate a population mean. So as soon as I hear that idea, assume a sample is being used to estimate a population mean, we're in this section here. So I'm looking at all of this content. Good. So find the margin of error that corresponds, and we're just looking for the margin of error that corresponds to a sample size of 17. So I'm going to write n is equal to 17 with a mean x bar of 58.7 and a standard deviation s of 15.8 at a confidence level of 98%. Perfect. Okay. So report the margin of error accurate to 1 decimal place because the sample statistics are presented with this accuracy. So one of the things I want to keep in mind is we had two tables that we're essentially looking at and using for our t-test and for our, well, t-scores, z-scores. Basically, that's essentially what we're doing. So for instance, if my z-score is 2.449 and it was two-tailed, I can calculate the p-value and then it presents the result below. With our t-test here, we would write down the degrees of freedom, we'd write down our critical t-value, and then we'd calculate it. So essentially, that's what we're looking for. So let me close this out. We essentially want to look at what's going on here in unit 8 so that we can figure out what that margin of error is. So we are going to note the formula, which is E is equal to our T critical value times the sample standard deviation divided by the square root of n. So recall that when we are looking at this t value here, we actually need our table. So we want our table. Let me grab
Oh,
my
it would be 2.33,
2.33. Let me just
right?
check for this one. Confidence level of 98%. That's in two tails. And then we know that our degrees of freedom is 16. I have 2.583. Is that what you said?
No.
So when I look at my table, let me just show you really quickly.
Oh, I'm using the wrong one. That explains it.
Okay, let me stop my screen share so everyone can see my table. Sorry that it's a little blurry. We know that we're looking at a 98% confidence interval. We also know that our degrees of freedom in my example, let me move this over. In my example, if my n is 17, my degrees of freedom is 1 less. My degrees of freedom is 16. So we go to degrees of freedom 16 under the column for 98% confidence, and I see a T critical value of 2.583. So we're going to use this information, 2.583.
How did you get
So
16?
2.583. 16 is found as degrees of freedom because it's always 1 less than the number of items you have in your set. So degrees of freedom are always n minus 1.
Okay, I'm gonna write that on my table too.
Yeah. So degrees of, oh, that's a good idea. Okay, hold on. That's a great idea. Degrees of freedom are equal to n minus 1. Good idea, Nick. Write that on your table. Why not? You should. I love it. Fantastic idea. So we have 2.583 as our critical value. We're going to multiply that by the standard deviation for the sample, which is 15.8, and then divide that by the square root of n, the square root of 17. And we're just going to punch that in. Let's see what happens. So we have 2.583 times 15.8 divided by the square root of 17. And let me look at the lumen to see what we have to round to. And
It gets to the nearest tenth.
Yeah, it is. So when you do this, you should have had 9.8982 da, 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 da. They wanted the nearest tenth.
So 9.9.
Perfect, 9.9. Let me go ahead and share my screen again with you. And here we would write 9.9 and let's submit it. And we're done. And that's number 4.
Okay.
Awesome. Awesome. I'm so glad that helped, Nick. See, it's good that we do these just to see like what process I'm taking and compare that with what you're doing. So that's wonderful.
You know what table I was using, which I don't even know why I was now that I'm thinking about it. I was using the critical values table. That was my issue.
Oh, the little guy.
Yep.
This little table. Yeah. Be
Yeah.
careful because this is for z-scores. I wrote z on top just so that
I'm gonna write that on there too then. I don't know what, that's why that's why I kept getting so confused because I kept doing it last night. I was like, why am I getting this wrong? And I was just getting annoyed.
Ah, that's the worst. That's the worst. Sudojini, you have a question?
Yeah. What and if we're given a I'm sorry, I'm out of it. That's why
It
I
breaks
can't
my
think.
heart hearing your voice because I know how much you are suffering right now. And I am so sorry. I really hope that like you are able to recover very fast. I know it's been a little bit. Ugh.
Yeah.
Anyway, sorry, go for it.
Thank you. So if we're given a like a problem, how we would know when to use the critical value or the T
Oh,
table. And I'm only asking this because most time, like I read and I get really confused. Like now, because I'm so nauseous all the time. That's why I
okay.
feel, I don't know.
I mean,
But,
that makes total sense to me. Here's my advice. When you are estimating a population mean and you do not know the population standard deviation, use this whole procedure. Okay, I would like almost cut and paste this and like put this exact wording on your formula page if you want. I will say for part one, you may not have to do too much of this, maybe just a little bit, but definitely put this somewhere on your formula page. If you are constructing a confidence interval estimate for the population mean, when the population standard deviation is not known, boom, this is exactly what you want to do. Notice here it says T sub alpha divided by 2. This is your T critical value, which is why you would use your T table. And once you use your T table, that's what tells you you need degrees of freedom. Okay.
okay.
If you are, and let me scroll up, I'm going to give you the other notes. If you are constructing a confidence interval for P, the population proportion, then you want, let me scroll up even more. Here we go. Then you want to use all of this information. Okay.
Yeah, thank
You're
you.
going to have your sample proportion, that right, your P hat, you'll find the Q hat divided by N. Your critical value in this case will be your Z score, which typically they'll ask for values within your common critical values table, like the 90%, the 95, all the way to 99. If you have any values outside of that, then we can go to the Z-score table and find our Z-score based on that information. Remember, all you do is you split up the area between the two tails, and then you look for the Z-score with an area to the left pertaining to the left tail. You would just go back to the table and you'd find it. Obviously, it would be a negative Z-score, so you'd want to take the positive value of that. Okay. But more often than not, they will give you, they will ask for something like the 90% confidence or 95% confidence. So your common critical values. So I would keep these two sets of information separate, and with the header, constructing a confidence interval for the population proportion. That's when you use all this good stuff. Sudojini, does that help a little bit?
Oh, yes, it does. Thank you.
You're very welcome. Number 1, yeah, Ava. So Ava says, let's do number 1 and number 8. So let's take a sneak peek. I'm gonna lower that. Okay, number 1, for a confidence level of 88%, find the critical value. So essentially what we're doing here is normally we would just use our table for critical values. And I just want to show you how, for instance, we would actually calculate this. So let me stop my screen share. And I want to show you the 90%. Now with the 90%, getting 1.645 is a little bit trickier because of the fact that we are typically, when we look at our work on the Z-score table, we will have values to 2 places after the decimal. But with the 88%, which is, by the way, which is nice, we have the table of common critical values. Well, let me show you what we would do for number 1. So we want the we want a confidence interval of 88%. So that essentially means we want to figure out what the z-score is that pertains to this region of 88%, right? So essentially we want to know what are the z-scores pertaining to this region. So what we say to ourselves is, if the middle is 88%, then we know that there's going to be 12% left over in the tails. Stop me if something doesn't make sense. There's going to be 12% left over in the tails, but 12% cut in half is 6%. So there's 6% area in this tail, 6% area in this tail. And we know that 6% is written as 0.06. Now that I have the area under the curve, I'm going to go to my z table and I'm going to go to the negative side because I want to start by looking for this z-score here. And I note that the area to the left is 0.06. So I'm going to go to my table and I'm going to look to see where 0.06 lies. Now I'm going to grab my pencil. I think you can see that 0.06 is somewhere in between these two particular values. So we just want to figure out which one it's actually closest to. So I'm going to say, well, 0.06, let's subtract and see which one it's closest to. Let me grab my calculator. What I'll do is I'll type in this first one, 0.06057. I'll subtract 0.06. So the difference between the first and the second is just 0.00057. All I'm doing is subtracting. I'm just trying to see which one I'm closest to. Then I'm going to take 0.06 and subtract 0.05938. Aha. It looks like it's actually closest to the region on the left, because the region on the left is 57 versus 62. When you subtract, you'll see the difference, 57 versus 62. So since I'm closest to the value on the left, this has a z-score of negative 1.55. So I'm going to write that down. Negative 1.55, which means my positive z-score is also 1.55. Using that information, I'm going to go ahead and go back to Lumen. Oh, what's going on here? Let me share my screen. And then I'm going to type in 1.55 and let's submit, and you're done. Beautiful. Ava, does that make sense to you now?
Yeah, a little bit. It's just like the chart kind of confuses me.
Yeah, just keep in mind that because we wanted the z-score, you just want to figure out which one you're closest to. What's going to help a lot is always draw the visual, fill in the region that they give you, and then say to yourself, well, what's left, right? And you split that between the two tails. I think that's going to be super, super helpful. Okay.
So it's just like 100 minus 88,
Yeah.
and then that's what gets you. Okay.
Yeah, exactly. Because if the whole curve were filled in, that's 100%. So you say to yourself, oh, okay, that just means that there's 6% left in each tail.
Okay.
Awesome. There was another question you asked for number 8. So we have, and let me write this down. We have that n, I like my pen. We have that n is 310. We have that p hat is equal to 0.22. And we want to find the margin of error at the 99% confidence interval. Good. So because we are estimating a population proportion, we want to write the formula for the error. So according to our notes in Unit 8, the error formula is z sub alpha over 2 multiplied by the square root of p hat times Q hat divided by N. So there's our formula. Notice that our confidence level is 99%. So we're actually going to use our common critical values for the Z-score. So 99%, when we look at this table, which by the way is in Unit 8, your 99% has a critical value of 2.575. So that's our Z. We're going to replace that with 2.575. We know that P hat is 0.22. What's Q hat? How would we figure that out? What's Q hat?
1 because of the 99%.
Oh, okay. P hat and Q hat go together, right? Think of success and failure. So soon as
So
we,
that would,
oh yeah,
so-
I always subtract from 100.
yeah. So if P hat, your probability of success is 22%, then the probability of failure is what's left over, which is 78%. So these go together. Think of these as a pair, success, failure, one and the other. Either it is or it isn't. So if your P has 0.22, your Q hat is 0.78.
I knew something. You had to subtract something from 100. I just don't know which one.
Yeah, just remember P and Q, they go together. They're always a pair. So if you know one, you know the other. So if P was 10%, Q is 90%. If P is 40%, Q is 60%. You see what I'm doing there?
Yes. Yeah.
Beautiful. All right, cool. So P hat, and remember, even if they give you 2 as a percent, you must turn it into a decimal. So P hat is 0.22. Q hat is 0.78. And we divide that by N, which is 310. So my advice for you all is I would punch in this square root piece first. So square root of 0.22 times 0.78 divided by 310. Press enter, then multiply by 2.575. What are you all getting for your error? And they want it to 3 places after the decimal. What are you getting?
Me?
Anyone?
Oh, okay.
Did anyone punch this in? What did you get? And 3 places after the decimal, that's what it's looking for. I hope you're getting 0.061. I hope that's what you're getting. When you punch this into your calculator, you should be getting 0.0605835593. When we round to 3 places after the decimal, it's 0.061.
I got 0.003. 4.
Do this for me. Let's do, so second x squared, which gives me the square root. And then I want you to type in 0.22 times, oops, 0.22 times 0.78 divided by, and all together, all at once, because there's no issue here. Divided by 310, close it, and then press enter. So that's the square root part. And now multiply that by 2.575. And then
Okay. No, I got it.
Four.
Gotcha. I was getting it wrong.
That's okay. That's okay. That's why I want to make sure we do it together. Beautiful. Let's go ahead back to our Lumen homework. And we have 0.061. And then we submit our question and we're done. Very nice. Excellent. Of course, Stephanie, you want to look at number 5. So let's check this out. The effectiveness of a blood pressure drug is being investigated. An experimenter finds that on average, the reduction in systolic blood pressure is 70.7 for a sample of size 501 and a standard deviation 21.6. Okay, so we're talking about an experimenter finds this information from a sample. So what I'm going to do right away is I'm going to write that n is equal to 501, x bar is equal to 70.7, and s is equal to 21.6. This is information from a sample of size 501. Estimate how much the drug will lower a typical patient's systolic blood pressure using a 98% confidence level. So 98% confidence. Good. So because we are again estimating the population mean, we want to use this same idea of using the error formula here. And then we have our interval x bar plus or minus the error. That's what we're looking for, but we need to use this formula here. So what we're going to note is that if our n is 501, our degrees of freedom is 500. Let me put another sheet of paper underneath this, so that way it looks a little bit better. Give me 1 second. And while I'm doing this, I want you to start to use your t-table, right? Start to think about that. So we have that our degrees of freedom is 500, and we see that our our confidence level is 98%. So let's look for degrees of freedom. 98.
I have a question.
Yeah.
So, mine says like, that the sample, size is 499. And so my degrees of freedom would be 498, correct?
Yes.
So what would you do in that case? Because I know it's not on the degrees of freedom,
Yeah.
498. Would you just round up to 5?
Yes. You always go to the closest one.
Okay. All right. I'm gonna write that down too.
Yeah. So for instance, if your degrees of freedom were like 413, you're closer to 400 than 500. So you'll use degrees of freedom 400.
Okay. All right. I was just wondering that. Thank you.
You're very welcome. So our confidence level is 98%. We want to go all the way down to where we see degrees of freedom 500. That gives us a T critical value of 2.334. So we're going to replace T in our formula. So E is equal to, our formula is right above T critical value multiplied by the standard deviation divided by the square root of n. So our T in this case is 2.334 times our standard deviation, which was 21.6, divided by the square root of n, and n in this case is 501. So we're calculating the error first. 2.334 times 21.6 divided by the square root of 501. So that gives me an error of 2.2523. And I'm writing the error to 4 places only because I want to make sure that I'm not rounding too much. If you look at the Lumen, it says enter your answer as a trilinear inequality accurate to 1 decimal place. But answers should be obtained without any preliminary rounding. So I'm trying to leave this to 4 places so that I'm as accurate as possible. I mean, I could even go 1 more. So 4 and 9, that would give me a 5, which is fine. It's going to be just fine. So we're thinking back to our inequality, right? The fact that we have to take the sample mean, subtract the error, and then take the sample mean and add the error. And that would present the bounds for a true population proportion. So our sample error is our sample mean is 70.7. And we're going to subtract the error 2.25235. And they want to 1 place after the decimal. So this is going to be 68.4. And now we're going to take the sample mean and add the error. And 1 place after the decimal, because this is 72.95, this is going to end up being 73.0. And that will present the bounds for this particular problem. So 68.4 and then 73.0. I can share my screen and put this answer so that you can feel confident about this. 68.4 and then 73.0, and then we'll submit. And
Would you do the same thing for question 6?
except this time we're doing the population proportion, but yes, same exact thing.
Okay.
Good.
Same
Very
formula
nice.
for
What's that?
question 6. Same formula for question 6.
No, because here we're using the population proportion. So you want to go to this part of your notes. So you're using your Z critical value multiplied by the square root of P hat times Q hat divided by N. They're very specific formulas. So if you're constructing a confidence interval for the population proportion, you use this information. If you're constructing a confidence interval for the population mean, that's when you use this information. Okay, so they're very different pieces of information, and you'll use them in their own particular scenarios. It's a process specific to what you're finding.
I had a question. I went ahead and tried to do my own equation, and I did it exactly like the steps that you did and stuff. And I got it wrong. I don't know what I did wrong. I don't know if you want me to read the equation or what you want me to do.
What I'll have you do, since we went over that question, is I'll actually have you click the Ask Your Instructor button. Send me that question just so I can look at all the data that you have, and then show me what you did. Like, show me a picture of like all of your work, and then I can help you troubleshoot.
Okay.
Okay.
All right. Thank you.
You're very, very welcome. I noticed yesterday when I was helping Stephanie that the questions didn't have this link, the message instructor, and now they all do. So I apologize that that wasn't there, but I fixed it and they all have the message instructor now, which is nice because I get to see the exact question you're looking at. Ho has asked for us to look at Unit 9 this time. Now, when you go into Unit 9 homework, I want you to have both of these links open, okay? And I do, I have them both here. And he had a question on hypothesis testing advanced. So let's look at this one. I'm gonna reset my work. And he wanted to look at problem number 2. This is what we're looking at, Ho, correct?
Oh, yeah.
Okay, perfect. So test the claim that the mean GPA of night students is significantly different than 3.5 at the 0.02 significance level. So one of the first things I do when I look at this information is I'm going to write down that my alpha is 0.02. That's actually really, really important. I write that down. So it's significantly different than 3.5. So the mean GPA. So we're not using P. This is proportion. Mean for the population is mu. So we're looking at either this option or the last two. Because it says significantly different, that means not equal to. So we're going to choose this guy right here. Mu is equal to 3.5. Mu is not equal to 3.5. Because we're using the not equal to, we realize this is a two-tailed test, right? This is a nice flow. We see that it's a two-tailed test. I'm going to make a note here, two-tailed. I'm going to note that my mu is equal to 3.5 and my alternative is that it is not equal to. That's something that we should essentially keep track of all that information. Based on a sample of 60 people, so n is equal to 60, the sample mean GPA, our X bar, was 3.47. with a standard deviation S of 0.07. So we want to find the p-value given this information. So as a recap, if we go to our Unit 9 notes, we're looking at the population. So this is an estimate for the population proportion. We want population mean. So let's scroll to that section of our notes. So we want the population mean. Here we go. And so we have our, we will only be covering when our population standard deviation is not known. So we're going to use the following test statistic. So we have T is equal to X bar minus the mean of the sampling distribution of sample means. So that's such a mouthful. Every time I look at it, I'm like, okay, prepare yourself. Divided by the sample standard deviation divided by square root of n. So that's how we would calculate our T values. So let me stop my screen share for a moment. Okay. We see here that our sample mean is 3.47. We know that our population mean is 3.5 divided by our sample standard deviation is 0.07 divided by the square root of n, and in this case is 60. So I'm going to do the numerator first, 3.47 minus 3.5. That's going to give me a negative 0.03. I'm then going to do the denominator, 0.07 divided by the square root of 60. That gives me 0.009036696. You're probably thinking, what in the hell? Remember, we're using online software to help us to calculate the p-value. So I want to have a t critical value for quite a few decimal places after. So let's take negative 0.03. We're going to divide it by 0.00903696. And that gives me negative 3.3197. And I can leave it like that. So 4 places after the decimal. And this is what we're getting. As a reminder, when you look at your Unit 9 notes, you can kind of think about the process that we actually took. So let me share my screen with you just so that I can remind you what's going on here. When we had a T critical value or test statistic of negative 2.242, we actually always took the absolute value of it, right? And then we found the p-value. So I'm going to take the absolute value of negative 3.3197, and that's your positive 3.3197. Let's go to our p-value calculator for a t-test. Our n is 60, which means our degrees of freedom will be 59. The t-value that we found was 3.3197, and now we're going to calculate. Perfect. As a reminder, our claim is a two-tailed test. So we found the probability here. So our p-value is equal to 0.0015487. Let's go into our lumen, and we want to 2 places after the decimal. So 0.00 is what we would end up with. Take a look. They actually say 0016, but it should accept 0.00. It's just kind of showing you that there are more values in that. When we make our decision, remember, we always compare the p-value with our alpha. Alpha in this case is 0.02. So we compare our p-value with our alpha. We can say that our p-value is 0.0015 and our alpha is 0.02. We see that our p-value is less. Ava, it gives us 60. It gives you the fact that there are 60 items in your sample. So when you take a look, it says based on a sample of 60 people, there it is, that's your N. So when we look at our notes, our p-value is definitely smaller than our alpha. And when our p-value is low, the null must go. So the decision is to reject the null hypothesis. So let's go back to our Lumen. And we are going to reject the null hypothesis, and then we will submit our question, and it is perfect. Paul, does that help going through that whole process, using the online calculator, all that good stuff?
Yeah. I try to do number because like this unit 9 assignment looks like a pretty much all the same concept.
Yeah.
And I try to do number 1 and number 3, but somehow it kept getting me wrong.
Okay, okay.
Yeah.
We could definitely take a look at number 1. You want to do that?
Yeah, sure.
Okay. So we want to test the claim that the proportion of people who own cats is smaller than 20% at the 0.10 significance level. So I'm going to make a note that alpha is 0.10. That's our significance level. And we want to look at the null and alternative hypothesis. So keep in mind of what we're saying here, and it's that we want to test the claim that the proportion is smaller than 20%. So we always turn this into a decimal point 20. So notice typically when we do it in class, we would say, okay, the null hypothesis is that our proportion is equal to 0.2 and that our alternative is our proportion is less than 0.2. So we want to find the one that's as close to that as possible. And again, even though we see it here, we can actually select it. We're going to say that our proportion is greater than or equal to, there's our equal to part, where our alternative is that the proportion is smaller than 20%. So it's less than 0.2. These two things should definitely be opposite. Whenever you're selecting them, make sure they're opposites. Okay. So because we're looking at less than, left-tailed, that's our test. Okay, it's a one-tailed test. It's a left-tailed test. Based on a sample of 300 people, N is 300, we're told that 16% owned cats. What does that value represent, that 16% in this case?
That should be, let me see, P hat.
Yes, beautiful.
Yeah.
So P hat is 0.16. Good. So we're looking at the proportion. Let's go back to our unit 9 notes. We're talking proportion this time. And I want to look at the formula, although it's right here. The formula is here again and again and again. So we want to calculate the test statistic. Go through this process as you work through your homework. So we calculate the test statistic. So Z is equal to P hat minus P divided by the square root of P times Q divided by N. As a reminder, P is 0.2. If P is 0.2, what's the value of Q?
0.8.
Yeah, 0.8, good. 0.8, because it's combined together, it's equal to 1. So let me stop my screen share so you can take a look at what I'm writing. And they always go together, that's why I paired them. All right, so P hat 0.16 minus P, which is 0.2, divided by the square root of 0.2 times 0.8 divided by N, which is 300. Let's do the numerator first. 0.16 minus 0.2, that's going to give me a negative 0.04. We have the square root of 0.2 times 0.8 divided by 300. That gives me 0.023094. Now let's divide those. Divided by 0.023094. And that gives me a Z value. I'll write that here. Z is equal to negative 1.73205.
Where did you get 0.2?
0.2?
Yeah.
That is from the Lumen homework itself. So notice that they're saying when we chose our null and alternative hypothesis, we see that P is equal to 0.2 and P, the alternative is that P is smaller than 0.2. So the population proportion is 0.2.
Okay.
Good.
I have a question, and that So if we did 0.2 and we said that's p hat, and I think, okay, well, 2 and 98 is 198 for q, that would be wrong.
98. Oh, I see what you're saying. No, because it's a decimal, you want
Mhm.
to subtract it from 1. If it's a percentage, you want to subtract from 100. Do you see the
Okay.
difference? So we want to be really careful with that. Okay.
Okay, this is gonna sound stupid, I feel like.
No, don't think that.
Where did you find p hat from?
Right here. So p hat.
Okay, okay.
Yeah.
That
p-
makes sense because I was trying to find it on my own thing and I was like, where is she getting 16% from? Because I kept looking up there at the top like before everything else, like, and I was trying to find it and I was like, I don't know where she's looking.
Yeah, and it's because we are told that we have a sample of 300 people, and we found that 16% of those people who are sampled have cats. So that's your p hat. That's your sample proportion. So good.
Okay, and then your P would be the 20%. Okay, that makes more sense. All right, thank you.
You're very welcome. So now we're going to use our online calculator. So with our z-scores, remember, we had never had an issue with having negative z-scores. So I'm going to punch in what I have here. So I have negative 1.73205. We remember it's a one-tailed test because this was a left tail test. So we just click one tail and we're going to calculate the p-value. We find 0.0416, and I think it wants it to 4 places. Oh, 2 decimals. So we are going to write 0.04, 2 places after the decimal, 0.04. Beautiful. Now
Wow.
let's compare. Oops, yep. Does someone have a question?
Are we allowed to use the Z calculator for the final?
No, you don't need it. You won't need it for the final. This is just for this homework assignment.
Okay.
Good. You'll just use your table. We're going to compare our alpha in this case, which is 0.10. So let me stop my screen share for a moment. That way you can see it. We're comparing 0.0416 to 0.10. We see that our p-value is definitely smaller. It's like 4 cents versus 10 cents. Okay. So we're going to compare those two. We see that the p is low, so the null must go. So let's reject the null hypothesis. Let's go back to Lumen and prove that that's exactly correct. Here it is. Reject the null hypothesis and let's submit. And ta-da, we're done.
That's interesting because that's what pretty much how I did, but somehow it got me wrong. Like I tried like 3 times and still got me wrong.
And did you use your z-score?
Yeah.
Okay, online calculator. All right, I mean, it might be just a very tiny error. So I would do the same thing. I would just select message instructor and then show me all the work you did. And then I bet anything is the tiniest error.
Okay.
Good. Very, very nice. Awesome. Let me look in the chat. Number 1 from chapter 9 basics. Sure. Let's take a look at number 1 from chapter 9 basics. Here we go. For the basics, I don't think you really need those 2 sites, but I'll just have that available. Okay, awesome. So 74% of people support the death penalty. Express the null and alternative hypothesis in symbolic form for this claim. So when you see something like this, Stephanie, what are you thinking about writing for your null hypothesis? What might you put?
The 74%.
Okay, and how would you write that in here? Because we have our P, which is proportion.
Wouldn't it be 0.74?
For sure. And the other thing we need is notation in front. So I would say P is equal to 0.74, and then P is not equal to 0.74. Because we want not equal to, it says enter exclamation point equals, that's what represents not equal to. and then we'll type in 0.74. Now, the other thing that may happen when we enter this is it may say, you know, this is unacceptable only because we're using equals here, but actually I think this is going to be fine just because it doesn't show it here. It's just showing you how you would input the codes if you needed it. So we have the proportion is equal to 0.74, and then the alternative is that the proportion is not equal to 0.74, meaning it's different. Okay, it didn't accept, maybe it's how I typed something in. Oh, you son of a, that is annoying. It wants us to actually write it as a percentage. That's the worst. Just to know on your part two of your final exam, write it as a decimal. Do not keep it as a percentage. That's an easy fix, and we got our points.
Thank you.
You're very welcome. Oh, you know why? Because I can't read. Express the null and alternate hypothesis in symbolic form for this claim. Enter as a percentage. Okay, clearly I can't read, so my apologies. Good. What else would you all like to see? It's nice because you have access to, you know, all of the Zoom recordings. You know, if there's a certain section that you're like, oof, I just don't know it very well, or maybe I just need to review it. You know exactly where it is, and you can go and watch the video again. Make sure you're doing that. Make sure you have your filled in notes next to you. If your notes don't seem very neat or organized, all of my filled in notes are here for you to use. You can print these out and have that next to you as you're doing your work, or you could just simply open them on your laptop or computer and follow along. So that's an option to you as well. Okay.
I've been watching you on fast speed, the recordings, and like this morning, I'm like, why is she going so slow today? Because I've been watching you fast.
Do that. You're able to speed it up just a little bit? What?
Yeah, I'm able, when I go into the recording, I go into settings,
Oh,
and from normal speed, I can speed you up however.
that's
I
pretty
want.
cool. I never realized that was a thing.
Yeah.
Ha, I see that playback speed. Oh my God, you can go to twice as fast. What do you choose?
Sometimes I do, if it's something that I know and I just want to brush through, I choose 175 or 2. You
Nice.
got to listen to yourself, and that you're like blah, 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 blah.
Oh, man.
Really fast. But you know, it's this morning, I'm like, she's slow today. Because like all night, like, you know, like while I'm laying down, I try to listen because that's all I can do.
That's awesome.
And
Yeah, I know. I'm glad that you're doing that though. That's resilience, by the way, everyone. That's what it looks like. Oh man, that's a perfect example of being not down and out. Down, but not out. You know, you're like, I'm still in it to win it, which is fantastic. And yes, this whole thing has been recorded. So I will be uploading this into Lumen, and it will have the little, you know, label of review for your final exam. I think we're all okay. I apologize that my formula page kind of looks like porqueria, but remember, it's just a guide. You're creating your own formula pages anyways. Just use it as a guide, and write down all the bits and pieces of information that you think will be helpful. Okay, definitely add your information from unit 8 and 9 on your formula page, just like those formulas, like how you would lay it out. Okay, I would definitely include that there as well.
Professor,
Yes.
will you be available for any of tutoring hours tomorrow on Thursday?
So what I planned on doing is having a review session for all of you this Saturday at
Okay.
1 o'clock.
All right.
Will that work for you?
What time? What was it? 1 o'clock?
Yeah.
Yeah, it's okay. Yeah.
Okay. All right. Perfect. So yeah, 1 o'clock this Saturday, we'll be doing review from 1 to 3. I hope that you can join me. I hope that that gives you more time to kind of dive further into the work. And then have questions ready by Saturday. I feel like that would be really worthwhile to everyone. Okay,
Yeah, I'm just gonna like stay whole night or something.
okay.
Okay, thank you so much.
You're very welcome. Good luck, everyone. You can do this. I have faith in all of you. I will see
Thank
all
you.
hopefully Saturday, if not Monday. Bye.
Bye.
You too.